All right, this is AP Calculus. Today's date is Monday, November 18th, 2019. Today we're talking about unique power and exponential antiderivatives. So our objective today is to find the antiderivative of functions that will be in log house and e house. And you might take a guess, the front half is probably going to be log house, the back side is going to be e house. So front side, let's talk about why we even need to create a new rule. Let's just say, okay, this was a problem on last night's homework or the weekend's homework. Let's use taxman, right? So taxman, we need three things. We need u, we need taxman, and we need u prime. So u is the inner. Oh, okay, so I can't really do this. I need to rewrite it first. So let's rewrite it first. This is now the integral of 12 times the quantity of 3x plus 1 to the power of negative 1. Still have that dx out there. All right, now that I've rewritten it so it's not a fraction, now I can definitely see, okay, u is definitely this 3x plus 1. 3x plus 1. Taxman, knocking at the front door, there he is, 12. And u prime is 3, which means I'm going to pay taxman. 12 divided by 3 is 4. So when I rewrite this using taxman, this is now the integral of 4 times 3x plus 1 to the negative 1 d of x. Okay, I mean, everything is going pretty well so far. Okay, now let's go ahead and anti-differentiate. So when I anti-differentiate, it's going to be 4, and then this is going to be 3x plus 1. And again, our rule is we're going to add to this, and then we're going to divide down by whatever that power is. So negative 1 plus 1 is 0. That's so far, I mean, that's kind of weird, that's 0. Okay, now I have to divide down by 0. So divide everything by 0. Okay, so you should see that this is not allowed. You can never ever divide something by 0. Even 0 divided by 0 is still indeterminate form, so nothing can be divided by 0. So this is bad. You can write this in all caps. This is bad. You need a different rule right here. So your general rule is going to be what happens whenever you have something to the negative 1. And here's a rule that you're going to write down here. We can call this thing, I guess I could make a new subheader. This is the log house. Log house. If I ever see, and I'm going backwards for log house, of course, if I ever have the antiderivative of something with a fraction, so like, let's just make it x to the negative 1 because we've already converted it out of a fraction. Let's also assume that we have some coefficient out here. It might be like 4 in this case. And of course we have d of x. The antiderivative of this thing will always, always, always be natural log of the absolute value of x. And I still need that a out front. And I'm missing something. What am I missing? That is right, my plus c. So there we have our rule. Make sure that you have this guy memorized. You guys are probably asking me now, well, why do you need to take the absolute value instead of just parentheses of natural log? And it has to do with domain. So this is the part where you can kind of stop writing. Let me go over here to a new tab. Let's go to Desmos to explain this one. So if you ever look at a natural log function, go computer, go computer. All right, so if I say natural log of x, notice that everything for the x and y values can be negative, y values can be positive, but x values cannot be negative at all. So that's essentially what we're trying to say. It's saying, hey, you can plug in anything for x. You used to be able to plug in anything for x. Look, I can plug in negative 1. In the original function, I could plug in negative 1, because if I plugged in negative 1, this would be 3 times negative 1, which is negative 3, plus 1, negative 2. This is negative 6. But when I take the antiderivative, if I plug in negative 1, natural log of negative 1, I'm no longer allowed to do that. If I come over here, well, negative 1 is right here. It doesn't exist. So in order to have a correct domain, you need to have absolute value. So I'll just make that note. For a correct domain, this guy right here. It doesn't mean we need absolute value when we take the derivative, but when we go backwards, you do need it. All right, I think I've kicked that horse long enough. Let's go to example number 1. Let's do taxman for example 1, and then we'll use u substitution for example number 2. Actually, vice versa. I have more room for example 1. Let's use u substitution here. So what are the 3 things that we need for u substitution? 2 things. Our u substitution, we need u, and we need our du dx. And first we need to rewrite the form. So this is going to be the integral of 6 times the quantity of 2x minus 1 to the power of negative 1 dx. And that's kind of the telltale sign. Oh, I have a power of -1. I'm probably going to be using this log house rule. So our u is 2x minus 1. Now I take the derivative of that and I get 2. And we are really good at skipping steps now. We need to solve for d of x. So that's going to be 1/2 du. Let's go ahead and make our substitutions. So after making our substitutions, this is now the integral. I still have the 6 out front. This inside parentheses is 2x minus 1, so I'm just going to make this u. That's u to the -1. This dx changes to a 1/2 du. So 1/2 du. I can simplify that a little bit more. 6.5, that makes 3. So I have the integral of 3u to the -1 du. And then from there, I can go ahead and take the antiderivative. So again, if I add 1 and divide down by 0, I can't do that. That's a kind of telltale symptom. But let's come up here, use this rule. So I still have a out front. I still have the 3 out front. And then it's going to be natural log. So ln, natural log of absolute value of u. And don't forget your plus c. And we're basically done. We just need to write it with the u substitute back in, this 2x plus or 2x minus 1. So the correct answer here is 3 times the natural log of absolute value of 2x minus 1 plus c, and we can box that. I realize also that we could have come back up here and solved this one. So let's go ahead and take a minute to come up here and say, okay, well, if I use taxman correctly before I do taxman again for example 2, which you guys should be able to do without me now, we did taxman everything correctly, but now we know this extra rule where we say, okay, we're going to use this natural log, so it's going to be 4 natural log of an absolute value, not parentheses, 3x plus 1 plus c. And there is our final answer. Let's make that in black, sure. For why we need a new rule. So you guys right now should be able to pause the video and do example 2 all on your own, and be careful about the du, dx, or the u prime in this case. So please use taxman to do example number 2. Alright, you've unpaused the video because you've attempted it and hopefully gotten it all, or most of the problem correctly. Let's try it out. So 3 things: we need u, we need taxman, and a u prime. Our u, and we don't know it yet because we have to rewrite the form. So this is the integral of 4 times the quantity of 1 minus t. If you make your t's curly, they don't look like pluses. To the -1 dt. And I think I've pointed out before, but I'll say it again, that whenever this variable is a t, this needs to be a dt. If this variable is a y, this would need to be dy. Otherwise, it doesn't work. So our u in this case is 1 minus t. Taxman is knocking at the front door. His name is 4, and u prime is 1 minus t. No, sorry, not 1 minus t. That was u. The derivative of that is going to be -1. So -1, which means I'm going to pay taxman the variable, or not the variable rate. I'll pay taxman the rate of -4. So here we go. We're paying taxman. I can come over here and do it to the right side. Rewriting the integral. It is now a -4, 1 minus t to the -1. dt still, and again, once I take the antiderivative, the integral symbol and then the dt disappear and are replaced with the plus c. So anti-differentiating gives us -4 natural log of absolute value 1 minus t. That should be an absolute value there. And don't forget your plus c. And there's our final answer. Change this to a yellow lemon, I guess. Not exactly the same color, but that works. All right, so these 2 questions are super common on the AP test, to the point where you should really just have them memorized. And like, you can probably see, okay, well, this is the same thing as x to the -1, because you can come over here and say 1 over x is the same thing as x to the -1, but you should automatically be able to transfer these as, oh yeah, if I take the integral of 1 over x, that is automatically natural log of absolute value of x plus c. Same thing down here. Oh, this is automatically what? You should just have this memorized, just very based on this form. Natural log of t plus c. Yeah, have these guys memorized, but I guess the more important rule to memorize is just how to take the antiderivative of loghouse. All right, that is the first part of our objective. The second part of our objective is ehouse. E-house is even easier. Again, let's use taxmin on this first one. Why do I need taxmin, by the way? I keep forgetting to ask. I need taxmin because the inner, in this case, is 4x. I'm always checking, is my dinner equal to 1? If it is equal to 1, then I don't need to use taxmin. So inner is 4x, so dinner in this case is equal to 4, which means I do need to use taxmin. So always check taxmin when you're going backwards. Do you need to use it? All right, so in this case, I do need it. So our u, we need a taxmin, and we need a u prime. So our u in this case is this upwards is 4x. Our taxman, he's knocking at the front door. There he is, 2, and u prime is 4. So I'm going to pay taxman 1/2. So rewriting this is now the integral of 1/2 e to the 4x. And e-house, I told you before, I'll tell you again, it is nice because e-house is just e-house whenever you're going forwards or backwards. So now that I'm going to take the antiderivative is just 1/2 e to the 4x. Ooh, there was a teacher error. You guys see it? And there was the teacher error. If you caught it, just log it. And there's the final answer. It's 1/2 e to the 4x plus c. And let's go ahead and box that. I'm just going to keep boxing it in red. Sure, why not? Yeah, you guys should be able to try example 3. I don't think it looks too difficult. Example 4 does look difficult. We'll do that one together. Yeah, pause the video now. Do example 3, please. And you have unpause the video. So here we go. I'm going to use taxman again. Let's use u substitution for example number 4. So taxman, that's not what I start off with. I start with u prime, and then I start with taxman after that. Taxman, and oh my gosh, this is what happens when you're sick. You just start messing up everything. And then u prime. All right, so our u is this 6x, whatever the power is. So 6x, our taxman is this -1/3, -1/3, and our u prime is 6. It's a little bit tricky to say what is 1/3 divided by 6, and you can do some scratch work out here. So what I'm really asking is what is -1/3 divided by 6, or divided by 6/1? It's a keep, change, flip it. So keep it, change it, flip it, and you multiply straight through. So it's going to be -1/18. Here we go. Let's change this form. That means I'm paying taxman at a rate of -1/18. Let's pay him. So we have integral of -1/18 e to the power of 6x dx. I didn't forget it there. And then we have to actually take the antiderivative, which is really easy. I just rewrite it, right? So antiderivative is just -1/18 e to the power of 6x plus c. And final answer, box it. All right, we're doing example 4 together. Let's go ahead and rewrite this form before we take, we're not going to do text, we're going to do use substitution. So how is this going to work? I'm going to rewrite it as the integral of 2t times the quantity of e to the, okay, so how does the negative work? Does the negative go there? Does the negative go there? In front of the 2, in front of the 4? It goes in front of the 4. So it's immediately in the power. That's the thing that becomes negative. So it's going to be e to the -4t squared. And I should put parentheses right there. Don't forget my dt. All right, so now I can see kind of what's happening. Let's go ahead and use u substitution. You could totally use taxman on this one still. We just want to get some practice with both. So u substitution, first we need a u, then we need a du dx. Sorry, du dt in this case. If this is dt, then the denominator is going to be whatever that is. So our u is clearly the power up here, which is -4t to the power of 2. -4t to the power of 2. I'm going to take the derivative. The 2 comes down in front. It becomes -8t. This goes down a power to just 1. That doesn't seem too hard, but now we have to do some rearranging. Let's take our time with this to make sure we're doing it correctly. Again, you're kind of cross-multiplying, so du times 1 is just du, and then dt is -8t dt, and we're trying to solve for dt. We're trying to solve for whatever that variable is, so we need to move this -8t to the other side, and that leaves me with dt by itself on the left-hand side, I'm switching sides also, is equal to negative 1 over 8t du. Alright, so we have our dt set up, we have our u set up. Let's go ahead and make those substitutions. So, coming down here, this is still the integral of 2t, that doesn't change. I could make that a better t, slightly better. This is all u, right? No, that's not. This is all u, e to the power of u. So negative 2t times e to the power of u, and that's going to be times dt, which is negative 1/8, negative 1, so that's a times negative 1/8, and t is on the bottom, du. We have some things to cancel out, so we have t on the top, t on the bottom. Luckily, those cancel out. Otherwise, I would be dealing with multivariable calculus where I have a t variable and a u variable. You can do it, but we haven't learned how to do that. I don't think we ever will learn how to do that, even in BC calculus, kind of like calculus 3 level. We can also cross cancel 8 and 2. 2 goes into 8 4 times, which means when I rewrite this integral, before I even take the antiderivative, I still have an e to the u. I have this negative 1/4 out front of it, so let me move you over a little bit. Negative 1/4 e to the u du. Now we can take the antiderivative, which is really easy because it's e house. E house is super nice. The antiderivative is the same thing, negative 1/4 e to the power of u. But instead of writing u here, it feels like I'm wasting a step, so I'm going to go ahead and write negative 4t squared. Negative 4t to the power of 2. And don't forget your plus c. Cool. So that concludes our notes for today, 5-4. Good luck on the homework.